Hey guys, here we are again. Would much rather be in class with y'all, but that is not an option right now. So let's get to work. Our next section is going to be 3.6, marginals, differentials, and linearization, although we are going to focus on just marginals and differentials. So for today's example, we're going to start with business functions, cost, revenue, and profit. So marginal cost, oops, so sorry. Let me get my pen working here. Okay, marginal cost is going to be the derivative of the cost function. Okay, marginal cost, the derivative of the cost function is going to approximate the cost of the next item. Okay, so this would be the C of x plus 1 minus C of x is the old school way of doing it. Okay, we don't need any calculus for this. The derivative is going to approximate the answer the old school way would give us. So let me give you an example of that. If I take the cost of 51, if I just plug 51 into the cost function, that would give me the cost for all, for all 51 units. Okay, what if I just want the cost associated with the 51st unit? Okay, then I have to take C of 50, which gives me the cost, oops, for the first 50 units, and I would subtract the cost of the first 50 units from the cost of the first 51 units, and that would give me that difference would tell me the cost associated with just unit 51. Not all 51 units, okay, but just that one single unit. We should be able to approximate that same amount by doing the derivative of the cost function. Okay, so on the next page, you'll see the same things are going to hold true for marginal revenue and marginal profit. Again, marginal revenue will be the derivative of the revenue function. Marginal profit is going to be the derivative of the profit function. And again, those are going to approximate the value that I would get by finding the revenue on the first however many units, let's say 50, and subtracting from that the revenue on the first 49 units. Okay, that would give me R prime of 49, okay, which is going to be the revenue on the 50th unit. Okay, not all 50 units, just the revenue associated with the 50th unit by itself. Okay, marginal profit, that same property holds true, so we won't go through the numbers on that. Okay, so if I have cost function and a revenue function, this example asks us for three things. A, total profit. Okay, so remember for profit, it's going to be R of X minus C of X. we want the total cost, the total revenue, and the total profit from the production and sale of 50 units. Okay, that means that I need to find C of 50, R of 50, and P of 50. Okay, so that is just plugging those numbers in to our original functions. Okay, and then finally, the marginal cost, the marginal revenue, and the marginal profit when 50 units are produced and sold. Okay, so C prime of X, R prime of X, and P prime of X. Okay, so let's take a look at those. So first we're going to do profit. So P of X is X cubed minus 12X squared plus 40X plus 10. And from that, we are going to subtract. Now, I'm going to go ahead and change my signs as I write it down. I'm subtracting the cost function, so that means that I need to change those signs. So minus 62x squared, this started out as plus 27,500, so now it's a minus 27,500. So P of X is going to be X cubed minus 74X squared plus 40X minus 27,490. Okay, so there's our profit function. We've answered part A. So for part B, we need to plug 50 into each of those functions. Okay, you can just do that on your calculator. Let's see what we get. I'll just go ahead and write the answers down for you. Okay, so 1 second here. C of 50 is 182,500. R of 50 R of 50 is 97010. Not quite sure if these numbers are turning out right. Okay, and then P of 50 should be 50 Yes, they are. Okay, so P of 50 is negative 85,490. Okay, so that is just old school plug and chug. Now we need to find C prime. So C prime should be 124x, I believe. Yep, 124x. And if we do C prime of 50, we get 6,200. Okay, that would be the cost associated with just the 50th unit. R prime is 3x squared minus 24x plus 40. So R prime of 50 Okay, so the revenue associated with the 50th unit is going to be 6,340. And then P, oops, I keep doing that, P prime of X is going to be 3x squared minus 148x plus 40. So P prime of 50 is $140. Okay, so we were operating at a loss overall, but you can see that on the 50th unit, we are starting to make profit as we go on through the units. Okay, so that's what a marginal tells us is, should we keep making this product? Are we making money on each additional unit? So on the 50th unit, yes, we made $140. We probably would want to try this whole thing again for 100 units and see how that looked. Okay. All right. There are two things here. One is delta y. Okay, and delta y is old school way. That means take the one bigger, evaluate it, take the one smaller, evaluate it, and subtract. You'll notice there are no primes in here. There is no calculus at all on this page. There are two different things that we're going to do. Delta y, I call it old school. It means we can do it without any calculus. We are just going to plug and chug. So for this one, we have x is 4, so, and my function is x squared. So I'm going to take 4, then it says add delta y to it, so I'm going to add the 0.1, and I'm going to square it. Okay, we plugged all of that in, the x and the delta x, in where x was. And then we're going to subtract f of x evaluated at just x. So that is 4 squared. Okay, and we get 4.1 squared minus 4 squared. So we get 16.81 minus 16, which is just 0.81. Okay, we didn't use any calculus there. We just put numbers in where they go. Okay, so this is one of the functions that you need to know. Delta y, the change in y, equals f evaluated at x plus delta x, meaning our new x value, and x, f of x evaluated at just x, and then subtract. Okay? We should be able, if our change in x is small enough, to approximate the change in y over the change in x. Okay, if we take and change in y over change in x, hopefully you recognize this as the old slope formula. Okay, so you'll notice on the last page we were solving for delta y. It was an exact calculation for delta y. Now we're going to approximate it using derivative. So let's rearrange this equation by multiplying each side by delta x. So if I multiply each side by delta x, okay, on this side I'm left with just delta y is approximately equal to the derivative times the change in x. Okay, so this is a formula that allows us to approximate what we would get doing that old school method from the other page. Okay, so let's look at that. We're going to approximate, yes, this is my favorite parlor trick. We're going to approximate what the square root of 27 is. Yes, I realize we can do the square root of 27 on our calculators, but you're going to have to show me all the work on your quiz, so I would suggest that you follow along and see what we need here. Okay. Now, in class, this is a little more easy because I'm able to talk to you guys and ask you all, what would you do if you didn't have a calculator and you had to approximate the square root of 27? Most of you would say 5 something. And then I would be able to ask you why you said that. And the answer I usually get is because 25 is a perfect square. I know 27 is a little bigger than that. The square root of 25 is 5, so it's a little bigger than the square root of 25, which is 5. Okay, and you would be absolutely right. And we are going to use that same information to help us out. So we're going to start by, let's see, let's do it this way. I want to rewrite all this. Okay, we are going to do a few things here. So x, we're going to let x be 25. Okay, now remember, the thing we are trying to get is we've got y equals the square root of 27. Okay, delta x, if we say that x is 25, well, really, the number we were looking at the beginning was 27. So the change in x to go from 25, the square root we know, to 27, oh, sorry, getting ahead of myself, is 2. Delta x is 2, okay? We also want the y value associated with 25. So y, remember our function, and we're going to take that out of the function, is the square root of x. So if we say that x is 25, then y was 5. We need delta y. We need to know what the change in y was. Well, remember, we're going to use that formula. Delta y is approximately equal to f prime x times delta x. Now let's see what we know here of this already. Well, we know delta x is 2. So we've got that part. F prime x, that means I need to take the derivative of this function. In order to do that, I need to rewrite the function. So y equals x to the 1/2 power. And 1 second here. Okay. Okay, so y equals x to the 1/2, which means y prime is 1/2 x to the negative 1/2. Okay, the problem here is usually I let you leave it in that format. But the problem with that is we have to plug an x value into this and evaluate. And my brain doesn't think in negative exponents. Maybe you're better at that than I am, and you are not allowed to use your calculator. So y prime is 1 over 2. That's the 1/2 from the beginning. What does that negative exponent tell us? Well, it tells us that x is going to the bottom. That would make that exponent positive. And the exponent of 1/2 tells me that it is in the square root. Okay, so I'm going to use that function over here, but this time I want to plug 25 in. So I have 1 over 2 times the square root of 25. And that's going to give me my delta y. So we have 1 over 2. Square root of 25 is 5. So I have 2 times the square root of 25. So that's going to be 10 times 2, which is 2/10 or 0.2. Okay, I'm going to take my original y, 5, plus my delta y. So y plus delta y, which is 0.2, and I get that the square root of 27 is 5.2. Okay, now that is going to show up on your quiz, and yes, you are going to have to answer for me what x is, what delta x is, what y is, actually no, what delta y is, and what the final answer is. You're going to have to do all 4 of those. So these 4 things are going to have to be identified on your quiz. Okay, another example that you can try if you want. And that is the end of tonight's lesson. So your quiz will have one of these on it, and it also has, sorry, let's go back. It is also going to have something here like this, where you have to do both. And let me go ahead and do that on here. So we had that delta y was 0.81. On the quiz, you will also be getting y prime, which would be 2x, and you're going to plug the numbers in and get that delta y is approximately equal to 2x, so 2 times 4 times 0.1. All right, that was my delta x. I'm using the delta y is approximately equal to f prime of x delta x. You will have to do it both ways. Those are 2 distinctly different ways. Does that, hopefully that makes sense. Those will be your 2 quiz questions. And that is all I have for you for this evening. So hopefully you are doing well. I will have another video up for you for 3.7 very shortly.